Now let's think about, we are going to apply this same thing to the graph. Tree was very good to search it in short way, the simple way, because it has lots of restriction. One of the restriction is each node has only go down to the children way. Children cannot go to the parents. But now, if it's a graph, it is possible bi-direction. So child can go to the parent too. Then another restriction, each node has its own children. Now, they can share the children. Why not? They can connect and every way, as an every way. That is a graph. Let's think about the almost the same thing with the graph. Then what we are supposed to think. First, I can start from initial. Yeah, that is still okay. Then if frontier is empty, yeah, I cannot search anymore. So this is good. Starts from A. Then remove choice from frontier. Yeah, it's also, I can do whatever way, then it is also okay. Then current state is pass that and good. The goal test is good. The problem is here. After I go B, I do not want to go back to A. For B, C, D, E, F, G. From B, I would like to go only C, E, F, G, not to the A. That means I have to do something. So I'm going to make one other set explored to reduce the chance to go back. So whenever I remove from the frontier, whenever I work on the current state, this current state will be added to explored. So one more job is here, add as to explored. Then when I choose the action, when I add the path, I can check if A is not in explored. Then I'm going to add the child to the path. Then there's one more situation is possible. When I go to my goal test, now there are lots of ways. Like after I go B, E, J, or B, F, A, or B, G, J, or B, G, and H. If I connect it here too, yeah. So many ways are possible to reach. So I also need to check if that path is already there or not. So if I show the example at here, let's think about this is current, let me say, yeah, this is current A. Then I can start from this one, it's initial. I can go A from here, or the other direction, or the other direction. So I can say if A is already used in other paths, I don't have to visit A again. So when I am at here, instead of going A, I can go down when the blue dot is goal. So without visiting A, I can find the other path. That means it also avoids redundant paths. The path repetition will be. Also, it is very good to find the shortest path too. So if A not in, explored, A not in, frontier path. So that means A not in the frontier whenever I have a path, as end, not as end. In that case, I can add path plus A into the frontier. Then let's see what I can read. So here, unless result S to A in frontier and explored, you are going to do the add A to the path, then the result will be added to the frontier. Then one more addition one. After I look at this one, I want to look at the next page. Now do BFS and DFS. BFS means use Q. We probably will use a pop 0, like what I showed at the previous slide. Then DFS is using stack. Last in, first out. So it's going to use in our code like a pop, means remove last.